Yo. So, it's been 4 or 5 months since the release of Qwen3.8 27B. And for those who know balls, remember...
What?
For those who know ball... Pause. For those who know ball, I don't know any balls.
Bruh.
I know at least 2 balls. For those with elite ball knowledge, you remember what it was like when that model came out. Even though you intuitively knew that local was headed in a good direction, that model really showed what the possibilities were. And it was very exciting. And now it feels like Qwen has done it again. Qwen3.8 27B is very good. There are some things that I want to comment on. We'll get into that later. But let's go ahead and take a look at some inference performance. So prefill, first of all, I ran this on a 4090 at a 4-bit quant from Unsloth. Prefill, how quickly you can get this stuff into the context before you start generating. Peaks out at 8K, 2359 tokens per second, degrades slightly at 120. If you're jamming in 120 off the jump, however, you're going to be waiting about 72 seconds. As we have here. Let's move on to decode here, generation speed. Not bad, a sustained 60 to 80. Okay, I tried this at several lengths, 32 up to 2048, and it does relatively well on my 4090 on a 4-bit quant. Moving on. Now, remember, no caching yet. All right, so let's move on to that in a second, but for now, let's just see how it does as the context fills up, okay? And then if you try to get it to generate more after the context has been filled to certain intervals, I did 8K, 32, 64, 120K, you can see the decode throughput. Now, remember, no caching right now. So at 120K, again, you're waiting a little over a minute to get that first token. Okay, here we go, caching. How much faster requests become when the long conversation is already represented in the cache. So we move from 72 seconds, which you saw up here on this chart, to 1.5 seconds almost. Obviously much faster, right? Here's a representation of both cached and non-cached. Pretty straightforward concept. I thought overall that it was very usable. It was fast enough for me at 4-bit. At 3-bit, even though I only ran a few tests, the quality was still pretty good and you'll use less RAM. I was pretty much almost at the limit, I believe 23 gigs, 23.5 gigs. At 131K context. In any case, let's move on to some concurrency tests here. I was not able to hit the limit. I actually had to run this a few times and I had to disable MTP to actually get the going. But you can see here at 8 agents, still pretty good throughput, 202, which is, I think, impressive. And that wasn't even the limit. So I actually then pushed it, I believe. Extended stress test. I moved from 8. We then went 16, 20, 24, and 32, looking at 330 aggregate decode without MTP though, remember. So all of the tests before this, I perhaps should have mentioned this, I had speculative decoding running, which you get out of the box with this model. And you're looking at about 11.4 tokens per second at 32 agents running. Let's move on to some things that I actually built with it. I made a game. I want to get into more complicated games, but we'll do that perhaps in another video with maybe a full precision. And then I did some practical sort of web dev and work related things. So I gave it a Flappy Bird prompt, which is something I do with most models. I think it's a canonical example along with a Kanban, which we're going to do next. Something I want to mention though about this model is that it's very pensive. Okay, it's very thinky, which can be good. Reasoning capabilities are one of the things that makes these models so good. However, this one thinks a lot. I don't know how else to put it. You can sometimes feel when a model is sort of talking itself out of solutions. It's a double-edged sword. The thinking and the reasoning can be good because it can solve things and think through edge cases, figure out how to solve certain problems. However, like I said, it can reason so much that it ends up doing the wrong thing. So my suggestion would be just turn it down to like a medium thinking, or off. It'll feel a lot snappier too. But if you don't mind waiting or whatever and using a lot of tokens, then it's probably fine. It performed well. So that would be my suggestion, just a little thing there. So let's take a look at the game. Okay, so this is a Flappy Bird, obviously, made with Vita. It's a full-on sort of React web app. And it works really well. You can see, keeps track of the score. Press click to start. I'm not very good at it. The physics are okay. The sort of graphics are fine. God, I can't focus and play. I don't know why I keep doing this test. Pisses me off. Come on. All right, I'm gonna focus. See if I can get to 10. Come on. All right, that's enough. Anyway, the game works well. It was one-shotted, one prompt. You could obviously make it better with follow-ups. I gave it the thing, it added sounds, and made the graphics. Okay, next task here is a simple sort of to-do Kanban board. Can move things around. It finished in about 5 minutes, took about 60,000 tokens. Now remember, I had thinking on at the highest, so you can always turn that down. Pretty straightforward. Everything seems to work. I can drag stuff up, open things, change priority, save. See if we make a new task here. Backlog, to do, call Jensen. Tell him about balls. Okay. All right. Anyway, it can do web dev stuff. Let's move on to a test where I have it use some skills. It has to follow sort of a logic thread, connect with an MCP, and see how it does. I did like it a lot better than Muse, and I'll talk about that in a second. So final test here, something that I would actually use a model this size for pretty often. Used about 120,000 tokens, took about 7 or 8 minutes. Now the thinking was on. That's probably why it used so many tokens. The context was almost full, which is fine. It was only one prompt. It is an options debit spread dashboard. It went into my Robinhood agentic. You can do agentic on Robinhood now, which means you can now kind of get data, which you couldn't do previously, which I really like. Now, should never let your Asian trade, but it's good for getting data. Okay, and Robinhood never had an open API now, so you can kind of do that, get stuff from your account. So here's an option debit spread dashboard, shows me my positions, and it used tools, skills, connect with the MCP, all by asking it with a relatively short prompt. Put it all together, follow a pretty long chain of reasoning, and create this dashboard. So you can see, had to make this profit calculator heat map thing. Now I did notice some don't appear. See, this one could be like a caching thing or something. I don't know. So it's not perfect, but it was one prompt, and you could fix it, talk to it as much as you want because it's local and it's yours and you're not paying Sam Altman. Okay. So that's a cool thing. Let's go and wrap this video up. Overall, I'm very happy with this model. I think it did live up to the hype. It's very thinky. Like I said, I don't even remember, which I did 2 days ago, Muse, Glimmer. Okay, I probably won't use that model that often. This blows it out of the water. It's similar size. Also, speaking of size, this model, I think I saw a benchmark screenshot somewhere, as good, if not better, on some benchmarks than Opus 4.6. Okay, and it's 27 billion parameters. How big was that model? I mean, we don't know. Trillions of parameters. So I think this is very good. I don't know what they're doing in China. I mean, they're incredible over there. Anyway, I'm happy with it. I will try maybe FP8 later and make a cool game or something. What sort of stuff are you guys doing? Are you running it on a smaller quant? Let me know what you guys think. Hit me up on Discord, by the way. I'm trying to have this old Discord I'm going to be in now. So hit me up and hit me up in the comments as well. Really exciting times for local models, I think. Okay, love y'all. See you in the next one. Bye.